So the lower left problem. We need to remember what we were doing from last time. We are solving by completing the square. What do we need to do first? We need to get the x squared term to be just x squared. Yes. It doesn't matter if it's a GCF or not. It must be just x squared. So we have no choice. We have to divide everything by 3. All right, so what does that give us? -1 equals 0. Okay, now what? Yep, so we're going to complete the square, so that means that the constant, the c, needs to go to the other side. So we're going to add 1 to both sides, and when we do, we're going to leave that gap that the -1 was in. So x squared plus 6x, leave that space, equals +1 now on the right-hand side. And now what are we going to do? We're ready to complete the square, so we have to remember how to do that.
Plug something in. You got to plug something into that.
Into the gap, yeah. How do we complete the square, basically, is what I'm asking. Half of the b term, so half of 6 is 3, and then we square that, we get 9. That is what needs to go in the gap. Just 9, yep, plus 9. So now we just added 9 to the left-hand side. So keep the equation in balance, so add 9 to the right-hand side as well. All right. Now what? We completed the square. Can't solve it yet. It's a perfect square trinomial on the left-hand side. And on the left-hand side, though, it's a perfect square trinomial, so we can write it like a perfect square. So it's now something squared equals 10. Basically, we're factoring the left-hand side. Yeah. So if we were just factoring the left-hand side, forgetting that it's a perfect square trinomial, two numbers that multiply to give you 9 and add to give you 6 are 3 and 3. So it'd be x plus 3 times x plus 3, right? Which is x plus 3 squared, okay? The shortcut to that is the x squared becomes just x. The sign of the middle term is plus, so we write plus. And then half of the middle term is 3, so that's going to be a 3, okay? That's what you do for factoring a perfect square trinomial. Okay, now what? Square root both sides. Now we got to solve it. So we square root both sides, and that gives us on the left just x plus 3. And on the right? No. Not quite, I should say. Yeah. Plus or minus. The square root of 10 does not simplify, so we just leave it square root of 10. And then solve for x. Okay, so what do we get? X equals? We subtracted 3 from both sides. -3. Good. And that's as far as we can go. That's our answer. We don't go to decimal on these square roots. We want the exact answer, not an approximation. Okay? Before you can complete the square, it must be x squared alone. Not by itself on one side, but it must just be x squared, 1x squared. Okay? So what do we do first on the fourth problem? It must be just x squared, 1x squared. So what do we have to do? Divide everything by 4. We don't have a choice. Okay? It doesn't matter if it's a GCF or not. We have to divide by 4. So divide everything by 4. Okay, what do we get? Yeah, that's 10/4, which reduces to 5/2 x. And now that's negative 3/4, that minus 3/4. I know I'm going to have to move it to the other side anyway, so I'm going to do it right now. So I'm adding 3/4 to both sides, leaving my space equals positive 3/4. Okay? I'm doubling it?
Half the b term squared and then squared.
Half of the b term. So what is 5/2 divided by 2? What is half of 5/2? I don't want decimals. I don't want mixed numbers either. Half of 5/2 is, don't give me mixed numbers. What's half of a half? Okay, so what's half of 5/2? 5/4. You gotta say it louder. I hear 2.25 and blah, 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 and I'm getting mad. Okay, so what did you say? 5/4. Now, that's half of the middle term, so what do we do with that? We square it. When you square a fraction, you square the top and you square the bottom. So what is 5/4 squared? 25/16. That's our number. That it? What I do to one side, I got to do to the other. So plus 25/16 on the other side. Okay, so we completed the square. We're ready to go. What do I do? Yep, this is now a perfect square trinomial, so we write it like a perfect square. And what's going to be inside the parentheses?
X squared.
Not x squared. X plus what? No.
You gotta go half.
It's half the b term. It's always half the b term. What is it?
5/4.
It's 5/4. It's just that number you use to get the 25/16. So 5/4. Okay. And now we just got to worry about 3/4 plus 25/16. Okay, yeah, we need a common denominator. What's the common denominator going to be? 16. So I got to turn 3/4 into something 16ths, right? What will it be? 12/16. So I have 12/16 plus 25/16. 37/16. Don't let the fractions scare you. And don't rely on your calculator. You don't need a calculator for this stuff most of the time. You can do this stuff in your head. Let your brain do it. Okay, now what? Square root both sides. Also, everything doesn't fall apart just because we see fractions. Okay? We're not doing anything different than what we've been doing. The math is not new. Okay, what do we have on the left side? X plus 5/4. And on the right-hand side? No. Plus or minus. Don't forget that. Write that down right away. Now, we saw earlier, like last week, that when we have the square root of a fraction, that we can turn that fraction into the square root of the numerator and the square root of the denominator. Okay? So if we think about this as the square root of the numerator, the square root of 37, 37 is prime. I can't do anything with that. So I'm going to leave it alone. Square root 37 over the square root of 16, which I can do something with. So that's going to be just 4. Once you take the square root of something, the square root symbol goes away. It's not the square root of 4 anymore. So it's just 4. Now what? We're going to subtract 5/4 from both sides. So this is x equals negative 5/4 plus or minus square root 37 fourths. Is this on the bottom? We're not looking at one on the bottom right now. I will address that question later. Well, so look at these fractions. What do you notice? It's a common denominator. So I can add these fractions together, and we're going to, okay? So we have, and I don't have room, so I'm going to write it here. X equals We have a common denominator, so over 4 is the denominator. And we can't add those numerators together, so we're just going to leave them alone. We have negative 5 plus or minus square root 37 in the numerator, and then fourths in the denominator, and that 4 is underneath everything. And that's our answer. The plus or minus is in front of the square root 37, and it stays there because that's how we found it over here when we took the square root of both sides of the equation. Okay? So that plus or minus stays on that square root 37. It won't move around. Now that we know how to complete the square and solve an equation, we can use completing the square to do something that we've wanted to do for a while, or at least I've wanted to do for a while because I knew about it. You guys didn't know about it. But now that you know how to complete the square, if you were to go back to the beginning of the chapter here and redo section 1, section 1, if you remember, was graphing a quadratic equation in vertex form. And then section 2 was graphing a quadratic equation again, but it was in standard form. And if you did that homework, and you did the homework from section 1, you probably felt like the homework from section 1 was way easier than the homework from section 2 because you realized that graphing in vertex form was far easier and faster than graphing in standard form because there was very little work when you're in vertex form. You can visualize the equation. You can almost graph the equation in your head in vertex form. You can do it very quickly, whereas in standard form you can't. You have to do some work. You have to do x equals negative b over 2a to find the axis of symmetry, and then you have to plug that into the equation to find the vertex itself, and then you got to set up your table and plot some points, and then use those points and reflect them. And all that time you could have been doing almost all of that work in your head in vertex form. Okay? So now that you know how to use the quadratic, now that you know how to do completing the square, you can take standard form and turn it into vertex form. And if you know how to do that, then you can graph in vertex form from standard form very easily. So that's the best part about knowing how to complete the square. Now you can rewrite an equation in vertex form, which will save you a whole bunch of time if you're being asked to graph an equation and the equation that they give you is in standard form. So it makes graphing, solving, and life as we know it a lot happier because it saves time. To rewrite an equation in vertex form, you follow the same process as completing the square, but now everything happens on one side only. Okay? And that's because we have y equals some equation. Whereas before we were solving the equation, we had equals 0, so we could work both sides of the equation. Now we have y equals, we're only going to work one side of the equation, so everything's going to happen on one side, which means we have to account for that as we solve. So if we do something to one side, rather than keeping the equation in balance by doing the same thing to the other side, what we're going to do is keep the equation in balance by undoing what we do on the same side. Okay, and you'll see what I mean here by that here in a second. So let's rewrite this first equation in vertex form. All right, what we're going to do is this. First, group your x terms like that. Then we're going to kind of treat that constant term just like our little brother, like we've been mistreating our little brother this whole time, or our little sister. I don't like mistreating my little sister, though, because I never had one. So I imagine I would probably treat my little sister better than I treated my little brother. So I always shove my little brother out of the way. So we're going to shove our little brother out of the way here, and we're going to create a gap so that inside that gap, inside the parentheses, we're going to have our fun while little brother is off to the side. And then in the end, we're going to bring our little brother back into the situation so that it looks like we're having fun with the little brother all the time. So we rewrite this equation. Y equals, and then x squared plus 4x, leave a space so we can have some fun, and then minus 6, little brother, off to the side. Now inside the parentheses with those x terms, that's where we're going to complete our square. So complete the square inside. Just like normal. Half of b is 2, squared is 4, so we're going to add 4 inside. Now we just added 4 on the right-hand side of the equation, which means now the equation is out of balance, right? Before, we were solving the equation, so we were working both sides of the equation, so we could add 4 to the other side of the equation. But now we're not going to do that because we're only working one side of the equation. So we need to undo what we just did on the right-hand side. So we added 4, which means we need to now subtract 4, and where we're going to do that is outside the parentheses, okay? So out here with little brother, we added 4 inside. We're going to take 4 away outside. So we added 4 and then we subtracted 4. In essence, we did nothing, right? We tied our shoes and then we untied our shoes. Nothing changed. But what we did was we created a perfect square trinomial. We tricked the equation into being something that it's not. So now we can write this perfect square trinomial as something squared. And then outside we have -6 minus 4, which is -10. And then inside we have just x plus 2, if I factor that into something squared. And now it's in vertex form. We can see that our vertex is at -2, -10. We have an axis of symmetry at x equals -2. It opens up. It's not dilated. And also, from the original equation, we have a y-intercept of x equals -6. We know everything we need to know about this thing. I see +2, which means that it's -2. Yeah. It's supposed to be x minus, and it's not. So it's x minus -2. So the second problem, what do we do? Group the x's. And then, rewrite it. So y equals x squared plus 3x, leave a space, and then the -6 outside. By the way, each one of these problems gets progressively more difficult as we go, okay? No. What do we have to do to complete the square? Half of b is what? Don't do that. 3 halves. Then what? Square it. What is 3 halves squared? 9/4. Square the top, square the bottom. So we have plus 9/4 inside. So we have to subtract 9/4 outside because we're doing the same thing, or we're working with the same side the whole time. Okay? Now what? Okay, rewrite the equation. The plus because that's the sign of the middle term. Half of the middle term is 3 halves squared because it's a perfect square. Now combine like terms. Common denominator is 4ths. So 24 over 4. So it's -24/4 minus 9/4, total of -33/4. And we're done. Yeah, it would be, and that's a good point. So would you graph using vertex form this equation? No, you wouldn't, okay? You might put it in vertex form because you're asked to, and you do have to find the vertex if you're using either form, right? The vertex would be what? -3 halves, comma, 33/4, -33/4. So you have the vertex, you can plot that, but would you use vertex form to continue to plot more points? No way, that'd be crazy. You would then go back up to the original equation and plot points from that equation, okay? But was it hard to put something in vertex form, even though you wound up with these fractions? Not really, okay?
Standard form's the one where you use the table and you plug in the points.
Right. But it would be pretty easy once you had your vertex here to come back up here and pick points off of the vertex and go a couple of points one way or the other and use those easy numbers in the original equation to come up with those easy points, right? It would be difficult to use this equation and do the same thing, okay? But it is not difficult to put it in vertex form to get the vertex, right? Okay. Okay, lower left, what do we do? Group the x terms. So what do we have? Okay, and then? Yes, half of b is negative 5, squared is positive 25, so plus 25. And then subtract 25 outside. So vertex form then is? Yes. Don't forget the squared. Minus 21 is right.
Why do we just, like, I feel like we're just leaving it unknown. Because, like, on this one, we kept going. Like, on the problem we just did before this, we just kept going. And this one, we were leaving it fixed. And on this one, we were
So you're looking at the problems that we were doing before we were putting things in vertex form. Those problems were solving the equation for x. These problems were putting the equation in vertex form. And that's it. We're not solving. However, if we were asked to solve, then we would make y equal to 0. So to set the equation equal to 0, and then solve for x. We'd add 21 to both sides, take the square root of both sides, add 5 to both sides. Okay? You can totally solve for x here easily by turning y into 0 and then solving for x. Okay? All right, do the fourth one on your own. What'd you guys do? We grouped it? Okay. Oh, okay. That's a y. Okay. And then plus 4 inside. Because half of negative 4 is negative 2, but squared is positive 4 anyway. Okay. And then outside adds to 0. So that's it. You're done. Yeah? It's minus. How come it's minus? This sign will match this sign. The sign in the middle term. Okay? Yep. That sign will carry through. Okay? Remember what we're doing. We're factoring that. Okay? So two numbers that multiply to give me positive 4 and add to give me negative 4. It has to be negative 2 and negative 2. So it's x minus 2 times x minus 2. And really that's x minus 2 squared. Okay? By the way, notice anything about this? Why is it simple?
The vertex is 0, 0.
The vertex isn't 0, 0.
No, something.
The 4 minus 4 outside added to 0, right? Look at what's inside. X squared minus 4x plus 4. That's what we started with. X squared minus 4x plus 4. The problem already was a perfect square trinomial. You didn't have to complete the square because there already was a perfect square.
So if that's the case, then wouldn't the first one be the answer? Right?
You would factor it. You wouldn't have to group it and do what we did. You wouldn't have to complete the square because it already was. You would just factor it immediately. Okay? But we didn't notice it. So it's nice to know that even though we didn't notice it and we completed the square, we wound up with what we would have wound up with had we noticed that it was a perfect square trinomial. Okay? Got it? The vertex is at what? Is at 2, 0. Where's the y-intercept? Where? No. No. Yes. Where did you get that from? It's in the original equation. It's the C value. And it's an ordered pair. 0, 4. At the bottom here, it's at the top of the next page in your notes, but at the bottom here it says, find the vertex and the y-intercept. So let's go back through and do the rest of these 3 other problems. First problem, what is the vertex? -2, comma, -10. And what's the y-intercept? (0, -6). It is an ordered pair. How about the vertex for the second one? (3/2), (33/4). And the y-intercept? 0, -6. And how about the third one, vertex? 5, -21. And the y-intercept? 0, 4. You get the y-intercept from standard form. You get the vertex from vertex form. So those 4 problems dealt with A was 1 on the x squared term. But if A is not equal to 1, then we have the same situation as when we were trying to solve the equation using completing the square. We must get A to be 1 before we can complete the square. Okay? So, but we're not solving the equation, so we cannot divide. What we have to do is factor out the A. Okay? So if A is anything other than 1, if it's 2 or 5 or -1 or anything other than 1, we have to factor out the A, even if it's not a GCF, from the group of x terms. Okay? And then we can continue from there. But, and this is important right here, when you subtract off to keep the equation in balance, you have to remember that you factored out that number, because that number times whatever you added in inside is what you truly added in inside, and then you're going to have to subtract off that number outside. Okay? So it gets tricky. It sounds really bad, but it's actually not that bad. It's not as bad as it seems. But you have to remember that this little thing right here is really important to keep the equation in balance. And we'll see examples of that here on these 4 problems. So take a look at the first one. What do we do? So first, group your x terms. Okay? Yes, you're only going to factor out what's inside the group. Okay? That's why you group right away. Now, there's a number, obviously, on the x squared term. We're going to factor that number out. Doesn't matter if it's a GCF or not. You factor that out. So we're going to pull that 2 out. So y equals, pull the 2 out. Now what's left over? X squared minus 4x. Leave a space. Now the plus 1 is untouched because we only factored out of the group. Now complete the square inside. So half of -4 is -2, squared is +4, so plus 4. Now, ordinarily, yeah, but there's a 2 out front. Okay, so if I distributed that 2 in, that plus 4 that I just added in would turn into a plus 8. So I wrote 4, but I really added 8. So I have to keep this in balance by subtracting 8 outside. And that's the but up there that I underlined. Okay, you have to distribute that number in your head to understand what you really added in inside so that you can undo that outside. So now we can write this in vertex form. Y equals, the 2 out front is still there. Our perfect square trinomial is now a perfect square. And then 1 minus 8 is -7. What's inside the parentheses is x minus 2. It's x minus 2, and that's squared. That's your vertex form. So we can tell now that this is a parabola. It's skinnier than normal. It opens up. It has a vertex at positive 2, negative 7. Okay, and from the original equation, it has a y-intercept of 0, 1.
Why is the 2 still outside of the parentheses?
The 2 is outside the parentheses because we pulled it out here, and it stays there.
Didn't you use it to manipulate?
No. We, in our minds, used it to figure out what it was that this 4 actually is. Because if I did distribute the 2 in, it would be an 8, but I don't want to distribute it back in because I want to leave it out. So that when I factor x squared minus 4x plus 4, it turns into x minus 2 squared, so that I can write it in vertex form. Because this has to be x squared here in order for me to be able to factor it into that there. Okay? So the second one, what are we going to do? Like I said, these get progressively tougher as we go. So group the x terms, and then we have to pull that 2 out. So y equals 2 times minus 3x. Leave your space. The minus 1 outside is untouched. Now what? Complete the square inside. Half of b is?
3/2.
So, yeah, negative 3/2. Now we're going to square that. It'll be positive 9/4. So plus 9/4 inside. So what am I going to do outside? I'm not going to subtract 9/4.
We got 2 times 9/4.
2 times 9/4. No. It's not 9/4.
No, that just simplifies it.
But what is that? What is it? 9/2. That's right. Here's a helpful hint. If you multiply a fraction by 2, the denominator gets cut in half. Okay? So like 3/4 times 2 is 3/2. All right? The denominator gets cut in half when you double a fraction. So 9/4 times 2 is 9/2. So what am I doing outside? I'm subtracting 9/2. Okay, we're ready for vertex form. What is it? Three halves. It's half of b. Don't forget the square. Don't do that. No, we're not doing that. Improper fraction. 11/2. 1 becomes 2/2. Negative 2 minus 9 is 11, so we have negative 11/2. Now we're done. Okay, so that one was a little bit tougher because of the fraction. Let's take a look at the third one. Yes, so group your x terms, and what do we see?
There's negative, which means it's just going to be x squared.
We have to pull the negative out, okay? So y equals negative. And then what are we left with? Plus 2x, right. Okay, and then plus 3. Now, complete the square inside. Yes, half of 2 is 1. Square that, you get 1. So what am I doing outside? I'm not subtracting. Why am I adding 1? When I distribute that negative in, what I really did here was I subtracted 1 inside. So therefore, to undo that, I'm going to have to add 1 outside. Good job. That one always throws people. Okay, we're ready for vertex form. plus 1. Okay. Yes. All right. All right, let's take a look at the fourth one. What do we do? Group the x terms. Now what? We have to pull that 2 out. What do I have? Three halves, x. Okay. The 1 is untouched. All right. Now what? Half of 3 halves is 3/4. Then square it. 9/16. No. There's a 2 out front. 9/8. Good, you're using that trick. So really what I'm doing outside is subtracting 9/8. Okay. Vertex form. Two times minus 3/4. Okay. It is negative minus 1/8. 1 turns into 8/8. 8 minus 9 is negative 1, so we have negative 1/8, minus 1/8. And we're done with the section.